Have you ever pondered the possibility of stepping into a machine, turning a dial, and then walking out into a different century? Time travel, a realm filled with mystery, has captivated human imagination since time immemorial. It challenges our understanding of reality and pushes the boundaries of what we consider possible. The concept of transporting ourselves to different eras, witnessing history unfold, or exploring futuristic utopias is captivating. Yet this tantalizing prospect presents some mind-bending challenges, with the grandfather paradox being a prominent one. Originating from the early 20th century, this theory presents an intriguing riddle. Imagine you traveled back and unintentionally caused your grandfather's demise before your parents' birth. This event would negate your existence, creating a paradox. But if you don't exist, how could you have initiated the journey back in time? The paradox presents a fascinating quandary about the potential pitfalls of time travel. Next up, we have wormholes, a theory introduced by Albert Einstein and Nathan Rosen in 1935. This fascinating concept, which has been a thrill for both scientists and science fiction enthusiasts alike, challenges our conventional understanding of the universe. The theory of wormholes proposes a shortcut through the vast, seemingly infinite fabric of space-time. Imagine this. In theory, these wormholes could act as cosmic bridges connecting two distant points in the universe. Instead of traversing through billions of light years, we could potentially step through a wormhole and arrive at a distant galaxy in no time. This concept, while intriguing, is not without its share of doubts and controversies. The stability of these cosmic bridges, these wormholes, is something that remains a point of contention among the scientific community. They puzzle over whether these wormholes, if they do exist, would be stable enough to allow for safe passage. However, the stability of these wormholes remains a subject of debate among scientists. Thirdly, we delve into the theory of cosmic strings, thin, elongated strands of densely packed matter that are believed to have been formed from the primordial soup of particles during the chaotic, explosive moments succeeding the Big Bang. These strings are not like anything we know in our common day-to-day life. They are more like wrinkles in the fabric of the universe, remnants from its birth, millions and billions of years ago. The concept of cosmic strings was first put forward during the mid-70s, a time of great innovation and intellectual exploration in the field physics. Scientists and theorists postulated that these cosmic strings, incredibly thin yet unimaginably dense, could possess unique properties. They have the potential to disrupt and twist the very fabric of space-time, a concept that is pivotal in our understanding of the universe and its laws. Under specific conditions, when two such strings, moving at high relative speeds, manage to intersect or get close enough, they could alter space-time to such an extent that it can theoretically distort time. This distortion could potentially allow for the phenomenon we often fantasize about in science fiction, time travel. Thus, this theory suggests that two such strings, moving at high relative speeds, could warp space-time enough to make time travel possible. The fourth theory, known as the time dilation theory, arises from the brilliant mind of Albert Einstein and his groundbreaking theory of relativity. Einstein's thought-provoking concept challenges our understanding of time, suggesting a unique perspective that the progression of time is not uniform but rather subjective to the observer. It introduces an intriguing idea that time behaves differently when in motion compared to when at rest. This principle of time dilation suggests that time moves at a slower pace for an object in motion compared to an object at rest. This is a rather counterintuitive notion, and it dramatically departs from our everyday experience. We generally perceive time as an absolute constant, unaffected by our movement or position. However, according to Einstein's theory, this is not the case. In simple terms, theoretically, a fast-moving spaceship could experience time at a much slower pace than here on Earth. A hypothetical journey into space, traveling near the speed of light, might seem to take less time for the astronaut than for someone stationary on Earth. The astronaut could return to Earth to find that more time has passed on Earth than for him during his journey. This astonishing phenomenon of time dilation has profound implications for space travel and our understanding of the universe. So, theoretically, a fast-moving spaceship could experience time at a slower pace than Earth. Next, we delve into the intriguing concept of the Tipler Cylinder, a theory brought to the forefront of scientific discourse by the innovative astrophysicist Frank Tipler in the year 1974. This unusual and captivating theory proposes a fascinating concept that challenges our perceptions of reality and time. It postulates that a cylinder, vast in mass and length if set to spin at extreme velocities, could potentially alter the very fabric of existence. As we journey into this thought-provoking concept, we must consider the physics behind it. The cylinder's immense size and rapid rotation could theoretically induce a phenomenon known as frame dragging. This is an effect predicted by Einstein's general theory of relativity, where the motion of a massive spinning body influences the space and time around it. According to Tipler's theory, this frame dragging effect can create significant distortions in the surrounding space-time continuum. This distortion could potentially lead to the formation of time loops, a much debated topic in both science and science fiction. These loops, if they prove to be real, would enable travel back into the past, a concept that is both thrilling and terrifying in equal measure. Lastly, it's important to note that while this is just a theoretical model, it is one that continues to captivate the minds of scientists and researchers worldwide. It suggests that a massive and long enough cylinder, spinning at high speed, could create a frame-dragging effect, warping the surrounding space-time and allowing for time loops into the past. Our sixth theory is the concept of quantum superposition, which is a fundamental principle of quantum mechanics. It's a cornerstone of quantum physics, dating back to the early 20th century, when quantum theory was first being developed by pioneer physicists such as Schrödinger and Heisenberg. This principle postulates that tiny subatomic particles, instead of having a definite place and velocity, actually exist in a haze of probability. It suggests that these particles can exist in multiple forms, in different places at the same time, until observed or measured. This unique property is what allows particles to exist in a state of superposition. It's a world where the usual rules of either or do not apply. A particle can be both and. Only when measured does a particle settle into one state. Shrouded in mystery, this principle has been the subject of intense scientific debate. Its implications are profound, as it opens up the possibility of parallel universes and, by extension, time travel. Finally, we discuss the Philadelphia experiment, a rumored military experiment from 1943. This clandestine operation was allegedly conducted during the height of World War II. The story revolves around the American naval vessel, the USS Eldridge. As per the myth, this US Navy destroyer escort underwent a transformation that seems right out of a science fiction book. The narrative suggests that the ship and its crew were made completely invisible to the naked eye, defying the laws of physics as we know them. But the tale doesn't stop there. Remarkably, it's also believed that the ship was teleported from Philadelphia, Pennsylvania, all the way to Norfolk, Virginia, in an instant. Despite the fascinating nature of this story, it's widely dismissed as a mere hoax by the scientific community, regarded as a blend of misunderstood technology and folklore. Yet, it's a captivating tale that adds a layer of intrigue to the time travel discourse. In conclusion, while time travel remains a captivating concept, it's steeped in complexities and paradoxes. This captivating idea has been a cornerstone of countless science fiction narratives, sparking our collective imagination. Each theory we've touched upon today provides a unique perspective, taking us deeper into the rabbit hole of time-related conundrums. From the grandfather paradox to the theory of relativity, these concepts challenge our understanding of reality. The ongoing debates within the scientific community are testaments to the uncharted territory that time travel represents. As we journey further into the cosmos, our exploration could potentially lead to groundbreaking revelations. Perhaps the answers to these mind-bending questions lie concealed within the enigmatic fabric of the universe itself. Only time will tell what secrets we may uncover. Until then, the concept of time travel remains a tantalizing possibility, forever on the horizon of our understanding.